Okay, it's 2 after, we can get started. Hello, I'm Randy Robb. I'm a principal consultant with Oxford Computer Group, and the topic of today is decentralized identity and verifiable credentials. This is a really interesting subject. I really like it a lot because it shows you can do all kinds of things with verifiable credentials that maybe you couldn't do before, and we're going to cover some of those things today. Basically, we're going to talk about decentralized identity and verifiable credentials and basically how they work. And I've got a demo that I'm going to show. And one of the things we're going to talk about is Microsoft Entra. And that's a new buzzword from Microsoft. And I'm going to explain a little bit about what that is. First of all, I want to talk about OCG. We have lots of years of developing identity management solutions and integrating identity and governance with all kinds of different platforms. Savient, we utilize Savient for governance a lot, but my specialization is actually in identity and identity solutions and integrating identity with applications, modern auth. I do have a MIM background as well. I know a lot about MIM and identity management, but I also have a developer background. So that's where pretty much my focus is in helping clients understand how OpenID Connect and OAuth work with the Microsoft platform and integration of the Microsoft platform with other types of identity providers. So we're going to talk about decentralized identity and what is it or what it is. And before I do that though, I want to talk a little bit about Microsoft Entra. Now they have rebranded several of their components and called it Microsoft Entra. And usually, really this is an umbrella concept of security, of identity and security. And it focuses not only on your identity of who you are within the Azure environment, but allowing that Azure identity and components of that Azure identity to be utilized across all kinds of different platforms. And they basically have split this up into 3 areas. The first one there is actually the identity infrastructure, which is Azure Active Directory. They say Azure Active Directory, but they really mean Azure Active Directory, like your Azure tenant, any external identities that you have integrated with your Azure tenant, as well as Azure AD B2C, which is not exactly an Azure tenant, but it's a authentication and authorization platform where you can customize it completely and integrate with other identity providers with Azure. It is Azure based. It uses the same components as an Azure tenant, but it's more open. You have complete customization over how those claims are authorized and come across. You can customize your login screen. You can use like tokens instead of an identity. You can use a hard token. You can do all kinds of things with B2C that you can't necessarily do right now with an Azure tenant. And it's mainly, it was originally created for like the customer end for businesses so that it handles like millions of identities. But in some situations, you can also use it to handle your own business applications. The middle part here is the permissions management, the Entra permissions management. There was a product that Microsoft bought. It was CloudKnox, and they've integrated it within this platform. And CloudKnox is a way, or the Microsoft Entra permissions management is a way to put all of your cloud service provider features under one identity umbrella. Like a lot of companies not only use Azure for their infrastructure, but they also use AWS, they use Google Cloud, they use all kinds of different cloud service providers. And you really want that to be under one identity umbrella. All of these actually fall under zero trust. So you really want to follow the zero trust model And that's part of what the middle solution is bringing that zero trust to your cloud infrastructure services. So you can manage everything from a centralized identity provider. And the last thing is the Microsoft Entra Verified Ideas, which I'm going to talk about today, that deals with decentralized identity. And I'm not going to explain too much about this right now because this is what I'm going to talk about. But this is a really, really cool feature of Azure. And a lot of other identity providers out there don't have something like this. It's a way that, and you'll see in the presentation, it's a way to bring a form of decentralized identity to your applications. So let's talk about decentralized identity. Basically, what I want to show in this slide is that you have a user, and then what they want to do is they want to get some type of resource. Now that resource can be like maybe pictures on your phone, or it can be an HR system connecting to that. You have certain resources that you want to get to that are protected like by backend APIs or backend databases. And the way that you interface with all that data is through an application. And it's that application's responsibility to make sure you are who you are so it can authorize you to that information. And that's what I want to show here, is that the application is actually the mediator between the actual data and you as a user. So what do you have to do? Well, in most situations, when you want to provide secure access, then you have to have some type of authentication, meaning that that person that is going to access that data to be authorized, you have to know who they are. There has to be some type of authentication there. So that can be your Azure AD tenant, that can be Facebook. If you log into Facebook, it says, okay, you are who you are because you authenticated. And then it can let you in and see your stuff. That's true across any of these platforms when you want to provide secure access. So here you can see that the authentication, before you can get to these apps, it can be Azure, it can be Facebook, your B2C tenant, whatever. That's the identity provider. And of course, the identity providers can offload their identity, your authentication, to another provider. Like if you have a B2C tenant, you can actually use your Facebook credentials to authenticate and get into those resources that are being protected by B2C. But there's some type of authentication that happens. And the problem is that, let's say you're using Facebook or Apple to get into your resources, and you violated something of Facebook, or maybe Facebook's whole infrastructure goes down, or you no longer have access for some reason to that authentication. At that point, you've lost access to your applications. If you use your business Azure account to sign up for something and you leave that company, then you may lose access to those things that are securing your information via the Azure tenant. So what are you going to do about that? Well, the best thing to do, what you really should do, is have your own identity provider that you as a user say, hey, this is my identity provider, trust me. I am who I am, and you authenticate basically to something that you own, and then you can get in. Of course, that is not that secure, because that means that all of these different applications would have to trust your identity provider that you have, and that is not really feasible, because who would trust a user that has their own identity provider? That's kind of silly. But that's really what decentralized identity is all about, is I have an identity that is separate from any of these other identity providers. So like I said, one of the ways that you can fix this is with verifiable credentials. Whereas you have, as a user, you have some type of identity store, but you get, it's not that the application is trusting your identity provider, but it's got to trust the claims that you get from somebody else. So possibly you could get claims from Facebook or claims from a government ID or claims from any of these um, issuers, and you could put them in your own wallet, and that's like a pseudo identity provider. So if you want to gain access to another to an application, and the application trusts that claim provider, then they can let you in. You just show your claims. Hey, I got these claims from XYZ, and the application says, oh, I trust XYZ. Okay, you can get in. So it's a way to give your own decentralized identity a way to actually say who you are, not because the application trusts you, but the application trusts where that claim came from and how you received that claim. So in order to get something like this to work, you have to have a very securely and tightly coupled trust, because between that claims provider and you as a user, when you have those claims, you know, how did you get those claims? If you present these claims to the application, how did you get them? How, you know, where did they come from? Did you steal them? You know, there has to be some type of secure way to get them, and a secure way for the claims provider, the application, to talk to the claims provider and verify that, hey, they really did come from this other place. And that's the main gist of verifiable credentials. The application needs to trust the claims provider, and it has to trust that you receive that claim in some type of, or that set of claims in a secure way. And as part of this process, those verifiable credential issuers must trust you as a user. The user must trust the credential issuer, and the credential recipient who's getting that credential has to trust the issuer. And so all these trusts are together. Well, what does that mean when we talk about trust in applications? Trust really means some type of certificate utilization. Anytime you go to a website, you make sure it's secure, it's because it has a certificate. It can verify that certificate. Certificates are the basis of trust in applications. So it just makes sense that verifiable credentials would have some type of certificate basis in providing this type of infrastructure. And so it's a logical thing to say, okay, well, if you need some type of trust and certificate management, what platforms are there that deliver this? Well, blockchain delivers this. That's a whole, even though you can look at the internet, and I even thought about explaining how blockchain works, but there's no reason really to do that, because the gist of blockchain, the guts of it, is the certificate management. When you create a blockchain environment, you have a certificate that's at the top level. And as each phase goes down, of course, you have a ledger. I'm not going to talk about all that stuff, but every transaction involves verifying those transactions with certificates. You as a user, when you own Bitcoins, you get your own private certificate that was generated by the certificate of the Bitcoin environment. So this provides a way to provide the this verifiable credentials, a certificate management system. That's why if you have Bitcoins, if you lose your private certificate, you're out of luck. You lose that, you don't have access anymore. That same thing is true here. So this provides a way that you can use some type of way to manage certificates, and that's why you have some type of blockchain environment with verifiable credentials. Here is a image that I got from this third party that I've got the link on the change. I was looking for different blockchain descriptions. A lot of them leave out the fact that there's certificates involved, and that I think that's probably a way to explain things to people the way that they can understand, but it's missing the guts of it, because certificates are everything. Certificates are how you make sure that the ledger is correct. private and public certificates are key. And I'm not going to necessarily go through this diagram right now because it doesn't really explain what we're going to do. The next slide is going to explain a little bit more. But I just wanted to show this, that blockchains and involve certificates to a big degree, and that's really the guts of it. So I'm going to demonstrate using Microsoft Verifiable Credentials, and this is pretty much how this works. So you have a user, Microsoft Verifiable Credentials actually integrate with your Microsoft Authenticator app. There is code available on Microsoft's website that shows you how to create your own wallet in code if you want to do that. But basically this provides, the Microsoft Authenticator provides the wallet where you keep your verifiable credentials. And this wallet has a backend interface with this blockchain network here. In this scenario, we're using the ION distributed ledger blockchain network. So the way that this works is that you want to get a verifiable credential. Let's say you want to get it from Woodgrove, which is the issuer. Then what you're going to have to do is go to that issuer and do something to verify that you are the employee. You have to either authenticate, show them your driver's license, do it in person, whatever. You have to strongly show that you are an employee. Once you have that, then what you can do with verifiable credentials is that a certificate is created with that verifiable credential and gives you this information that you can keep in your wallet. And this is an example of a digital signature that you actually get from Woodgrove here, the issuer. It's put on the network, and then you receive this as part of your Microsoft Authenticator integration, so you now have that credential. So this has been securely obtained from Woodgrove through this ION distributed ledger via the certificates, and given only to you by your certificate integration with your Microsoft Authenticator app. So you go to someone to present that certificate, right? You're going to say, you're not going to authenticate. You don't need to authenticate. All that you need to do is say, hey, look, I have this certificate. And because there's a strong trust between here Prosware and Woodgrove issuer, they know that the only way you're going to get this verifiable credential is if you went through some type of vetting. And because this is tied with the distributed ledger, it knows it can trust you and it can trust the certificate. So when you present this, or the verifiable credential via its certificate, so when you present this, Prosware will say, hey, it looks like the certificate is correct. It looks like you have it. Let me check. So it looks at the certificates involved with the credential. It goes back and it verifies, yes, it did come from Woodgrove. It did come from you. Yes, this is correct. Then it's going to let you in and do whatever you need to do. And so now you've basically proxied the authentication in a way from the original Woodgrove issuer via the trust of this verifiable credential. And let me see if I have any questions. No questions, I guess. Okay. So, and this is pretty much what I was telling you before, why you use blockchain. The main reason is because it provides a platform for public and private certificates. It's its own PKI that you can use to back channel the verification of the certificates involved so that you can securely transfer those verifiable credentials from one place to another. And it also provides ledger capability. So you can actually see the history of everywhere that verifiable credential has been used, who has read it, who has obtained it, where it came from, the origin of it, as well as actually expiring it. So it basically provides that complete life cycle of those verifiable credentials. Now comes the demo part. So I created this demo to show how verifiable credentials could work in how they can work basically in just about a lot of different scenarios. In this one, I actually do a lot of paintings, and I sell some of my prints and stuff. And what you can do with these prints. Let's say I wanted to make some prints. Of course, I can go to the website and make prints. But I also have a website where I have copyrighted images. Well, anybody can screen capture an image. And if, let's say they wanted to make a print, they're not the copyright owner. They can actually go to a printer and upload an image. The printers don't check. And there's no way for me to easily copyright my image and prove that I have that image copyrighted. I can actually go and copyright it, of course, but then it's just difficult right now. And so what I wanted to do is show that, hey, what if we had the copyright organization? You could actually submit an image, have it copywritten, and then get a verifiable credential that you own that. And then what a printmaker would have to do is have to verify that you own that copyright image. You present that verifiable credential to the copyright maker or the printmaker, and then you can have your print made. And they'd have to have controls, of course, to say that they're not only going to allow a public domain or verifiable credential prints to be made. But this is only a demo, so it's only a a made-up thing. So I'm going to show a little bit of the background. Basically, this is what I just explained. You have a painting of the photograph that you want to have copyrighted. So you're going to take it to the copyright provider, and they're going to do some back-end verification. Now, I don't do this in my demo application. I basically have just assumed that that's done. But once it's verified, then they'll give you a verified credential that represents that image. And then what you can do with that verified image is go to a printmaker. They're going to verify the ownership of that verifiable credential, and then you can go ahead and have your print made. These are the components that I'm going to show you. These Blazor applications are going to look very similar. That's just because I just created them for demo purposes. But I actually have a Blazor application that represents the copyright owner verification. This is where I'm going to get my verified credentials from, and I'm going to present it to my backend, this printmaker. This is an application that represents a printmaker that's actually using Azure AD B2C to ingest those verifiable credentials. And then on the back end, I have an Azure AD tenant that actually is issuing those verifiable credentials, as well as having a storage for my images, so that the printmaker can grab the images directly from the tenant or directly from the application that is housing the copyright ownership procedures there. So what I'm going to show you is a user signs in to the copyright site. He's going to upload an image. Of course, this is not part of the solution, but he's going to determine if it's copyrightable or not, or public domain. It's going to say, hey, yeah, your image is copyrightable. So you get your verifiable credential here. You get a public link of the uploaded image, which is part of the verifiable credential. And now you have your verifiable credential, and you can provide it to another organization for printmaking. And this is just the other flow chart where you can present your verifiable credential to the store. You scan your QR code so that they can obtain the verifiable credential with the image embedded in it. And then once they verify it, then you can make your print. So I've got some slides here just in case my demo doesn't work, but I'm going to show you a live version of this right now. Okay, so here's the app. So the very first thing I have to do is log in, because it's going to associate my copyrighted image with some login. So let me log in here. Let me log in. Okay. I'm going to sign in. So now I have the ability to copyright an image. So if I go to copyright here, I'm going to choose a file. And I go to choose a file. Those are some of my paintings there, but we're not going to do that right now because they're kind of large. I'm going to go to my desktop, and get some demo images. Here we have some cute dogs. And let me go ahead and say that this is a painting. Let's imagine I'm going to upload this image. So while that's uploading, it uploaded the image. Now it's going to give me a QR code. Now what I'm doing here, which you can't see, unfortunately, you can't see what I'm doing, but I'm going to my Microsoft Authenticator app, and I go to credentials, and now I'm going to scan the QR code. So I'm scanning the code now. You can see that this is going to change. So now it's going to ask for my verification code. It's kind of a two-way. Usually you would get this in a separate, some separate way, maybe through email or something. Just for the demo purposes, I'm putting this up here. It's like a second form of authentication. And then I get my credentials, and I've issued it. So just to show you kind of what that looks like here. Here's where I would put in my code. I'm adding the credential, and so this is what I see. You can actually customize this. I was thinking about putting the image in back of this so that you can see the image there, but you know, this is only a demo, so I didn't do that. And so back here, we're here. So once we have this, we can actually verify the copyright as well as a verification, and you probably should do that once you do that. But I'm not going to show that right now. We're kind of short on time. I want to make sure there's time for questions. So anyway, so I've got it. I've got this credentials. It's a verifiable credential. It's part of my Authenticator app. It's within my wallet on my Authenticator app. So what can we do with this? Well, let me open up a new incognito window here. So now I'm going to go to a different application. This app actually represents the store. This is running on using Azure AD B2C as the identity provider. And you can see there's no login here with an identity. All I can do is log in with my copyrighted image. So basically what I'm going to do is log in here, and it's going to give me a QR code to authenticate with. So I'm going to go to my credential wallet on my Authenticator app, and I'm going to scan this, and it's waiting for validation. So I have to validate that, yes, I want to give this credential. So I'm going to give the credential, and I share it, and now I'm saying, yes, you can see this credential. And so what this application has done is on the back end, you didn't see any of this happen, but my Authenticator app, I allowed my credentials to be delivered to this application. And this happened on the back end ION network. Like we said, we exchanged it, it went on the ledger. It actually, on the back end, grabbed that credential, I approved it, so it now could be read by this application. So now it ingested that verifiable credential. It knows who I am because I authenticated in that other app with my ID. It knows who I am here. In fact, I can look at my claims, and it can say where the claims came from. It actually came from that other identity provider. But because I've got some information in my verifiable credential, not just my name and where, you know, that I got this from the Copyright Office, but I can also view the image because this image is part of my verifiable credential. The link is there. And because there's a trust between this store and the copyright registration environment, I can actually grab that and view it. And from there on, I can order the prints because my verifiable credentials were identified and verified. So that's about all I have for the presentation. If we do have questions, I'll be happy to answer questions. Let me see, are there any questions? No questions, okay. There is. Will there be a universal distribution ledger? I think that there probably will eventually be. There'll have to be a trust between the different ledgers, right? Because if Microsoft use the IAM network or they use something else, maybe Okta, if they do this, will use something else, or Ping, whatever those identity providers are, they may choose somebody else. And so there has to be some level of trust. Now, what I would expect is that there would be different layers of these different blockchain environments. Like I said, the key to this whole blockchain environment are the certificates and the security. I could imagine that maybe governments would provide a blockchain for identity, just like they're thinking about providing some type of digital currency. They would present their own blockchain. And so there'd have to be a trust between, let's say, the ION environment and this government blockchain. So yeah, that's how I think it would work. Okay, if there are no other questions.
Hey, Randy, you did get one more question.
Oh, I see. This silly thing. I can't really see what it is.
What was implemented in the B2C custom policy to sign in? Some API?
Okay. Let me show you that then. I'll be happy to show you. This is using older code. This was actually developed back in March or April, and they've actually changed some of the internals. But I'll be happy to show you the what the code is involved with the B2C, and it's kind of difficult. It was kind of difficult to integrate with B2C because I had to get that QR code. If you want to wait a second, I can bring up the code. I have to find it because I have a cleaned version of it here that I can present. So one of the things that I needed to do is actually have a custom policy that I created for the copyright information and the QR code. If you worked with B2C, you know that you can customize the presentation screen of the sign up, sign in policy. And in order to bring that QR code, that screen needed to be customized so that it talked to a backend service that would generate that QR code based on some internals to B2C. And if you look at the API that I'm integrating with, you can go on GitHub. I probably do have this on GitHub. Sorry, I don't have the link. But if you look up I think it's under my randy.robb@outlook.com. There is this code there. It's a clean version of that code. So it should be out there on GitHub. But what I have to do is grab the talk to the backend service, the authentication state provider here on the here. No, that's not it. Sorry, but I'm not sure where it is right now. But basically what you have to do is you have to go and talk to the backend Azure tenant where these verifiable credentials are stored. You need to have a claims principal. You need to set those up appropriately so these applications can grab them securely. So anyway, I would just advise you to see if you can find my GitHub repository. And you can see how it's done. Is there any other questions that I missed?
Looks like I have a couple more. If
Really?
the blockchain provider is unavailable or no longer exists, the whole process falls over?
Yeah, I guess that's true. You better hope that it doesn't disappear. That's the
That's
same thing with
fantastic.
Bitcoin. With Bitcoin, it's gone. All my money's gone.
I don't think
Okay.
any more questions are coming in.
Okay. Well, thank you guys, and thanks for providing feedback and or at least asking some questions. You can go out to, and if you go to Microsoft's website, you can find sample applications that they have. And I'm sure it's a lot. It was kind of difficult to get these demos working back in March because they didn't have everything fleshed out yet. And they're a lot better now. In fact, I need to redo these demos to incorporate the new code. So just take a look at that. So thanks, guys.